Modern full-stack development requires rigorous architectural judgment. The role centers on building an impenetrable core that anchors every user interaction. While the front end governs the user experience and guides workflows, the backend acts as the unyielding enforcer of the rules. Shallow or inconsistent backend design introduces severe risks. It leads directly to silent data loss, unreliable APIs that break integrations, and security gaps that leave the entire system vulnerable. AI coding agents can generate implementation code rapidly, but speed does not guarantee structural integrity. The developer remains uniquely accountable for evaluating the risks within the generated logic. We are going to construct a resilient, production-ready backend system from first principles, taking a fragile, naive script and reinforcing it layer by layer. We will cover the 10 core backend responsibilities of full-stack developers, moving step by step from basic data integrity all the way to full operational maturity. Every backend must operate under a single assumption. The client is unpredictable and potentially hostile. The backend is the product's ultimate trust layer. A naive implementation connects a UI to a database via an unvalidated pipe, where raw data slides through. To fix this, an API router drops in, forcing data to comply with a contract. Next, a business rules filter drops in behind the router, independently verifying every action. Invalid requests are rejected instantly. For example, the backend must ensure that a task status only moves through allowed transitions, or that an AI-generated review finding requires explicit human approval before a task is created. Beyond workflow rules, the backend serves as the final defense for the data itself, ensuring every record is valid, consistent, and safe before it touches the database. As this list shows, protecting data integrity means actively managing required fields, enforcing correct relational mapping, handling duplicates appropriately, and executing safe updates. Poor data design creates irreversible, long-term product pain. You cannot fix corrupted database relationships with a user interface patch. Without strict API contracts and independently enforced business rules, a database quickly deteriorates into a corrupted garbage dump, destroying the application's underlying value. Relying on the front end to hide sensitive workflows is like putting a freestanding door in an open field. Attackers step right around it. Malicious actors bypass the UI entirely. They send raw requests directly to unprotected backend API endpoints. To prevent this, a rigid authorization gate locks into place immediately after the API entry point. Nothing passes this barrier without scrutiny. Before processing any logic, the backend evaluates these specific questions. Who is the user? What role do they hold? And are they permitted to perform this specific action? It is not enough to simply identify who has logged in. The system must actively verify their specific right to access or modify the requested resource. Permission enforcement is strictly and exclusively a backend responsibility. Any system relying on client-side hiding for security is compromised from the moment it is deployed. Moving past the authorization gate, we examine the backend's internal processing core. Blending routing, logic, and data access creates a tangled knot of overlapping code. To fix this, the architecture must snap into 3 strict, non-overlapping zones: route handling, business logic, and database access. Maintaining these clear boundaries is the primary driver of long-term system maintainability. These boundaries directly enable testability. If a backend is hard to test, its design is weak. Developers must consider multiple layers of testing: unit tests for business logic, broad API tests, database behavior tests, and explicit permission tests. Modern developers frequently use AI coding agents to write the code within these specific routing and logic blocks. While agents accelerate implementation, they must never be allowed to silently dictate the backend architecture. Full-stack developers must manually review agent output, specifically scrutinizing the proposed architecture, the data models, and the permission checks. AI can rapidly draft individual functions, but structural integrity, boundary enforcement, and overall security rely entirely on human judgment. Even a fully protected system will eventually encounter unexpected states or failures. We have to design for what happens when things break. Error handling has a dual mandate. It must return useful, graceful error responses to the client while simultaneously avoiding leaking any sensitive technical details. To manage this, an internal observability shell wraps around the entire pipeline, routing alerts to a secure monitoring console. Logs must capture important operations, integration errors, and permission denials. Crucially, they must never expose environment secrets or sensitive user data. Writing the code is only half the job. Working locally on your machine is vastly different from operating in a live, real-world environment. Developers must anticipate operational constraints, from configuring environment variables and Docker setups to managing external dependencies. You must carefully manage database migrations and account for the configuration differences that exist across staging and production environments. This requires monitoring live service health and preparing strategies to manage rollback risks during a deployment. A backend is only as resilient as its deployment infrastructure. Unmonitored or poorly deployed code is simply invisible technical debt waiting to fail. Look at the fully constructed trust layer. Data flows safely through strict validation rules, passes authorization checks, navigates clean logic boundaries, and commits to the database, all fully monitored. Good backend work is highly structured, testable, properly validated, and secure enough for the use case without being over-engineered. Conversely, weak work is characterized by generic error responses, missing migration notes, and black box agent-generated code that the developer cannot actually explain. Technical decisions must actively support the product's long-term business direction. If a product might later support multiple clients, the backend data design should avoid hard-coding an internal-only access model without clearly documenting that limitation. The backend functions as the foundational layer of product trust, ensuring data correctness and system reliability regardless of client-side behavior. Effective full-stack development extends beyond the happy path. It produces features that are safe to use, easy to debug, and prepared for future scale.